The outlook around climate change is dramatically different in 2025 compared to even just a few years ago. You already know that climate change is incredibly important, but maybe you haven't kept track of all the different moving pieces because it can understandably be pretty overwhelming. There is so much more to climate change than just reducing CO2 emissions. So in today's video, I'll get you completely up to speed on where climate change stands in 2025 by covering 10 must-know concepts and insights that are shaping the conversation today. Hello friends, if you're new to this channel, my name is Kevin Yang, and I've spent years as a climate and impact investor helping mission-driven businesses tackle the climate crisis head-on. I am obsessed with the idea that business and finance can be a force for good in this world, including for our planet and its people. So let's dive in. Let's start by just taking inventory of where we stand in 2025 compared to the targets that we set forth a decade ago. This is in 2015 and 2016 when we signed the Paris Climate Accords, which is basically an international treaty that came out of the UN Climate Conference that says we're going to try and limit global temperature rises to well below 2 degrees Celsius compared to pre-industrial levels. And we're going to pursue trying to limit these global temperature rises to only 1.5 degrees Celsius. So pre-industrial, you can think of this as around 1900. And then for our thresholds, 1.5 and 2 degrees Celsius, there's nothing that's magical about these numbers, but we basically know from climate scientists that above these different thresholds, the likelihood for different tipping points, such as extreme weather systems or glacier and ice cap melting for sea level rises, could really accelerate and wreak a lot of havoc. For context, at the time of signing in 2015, we were at about 1 degree Celsius of warming compared to pre-industrial levels. Depends on who you ask. Maybe you might get 0.9, maybe as high as 1.2. So how are we doing on this first threshold, 1.5 degrees Celsius? We are basically at or very nearly approaching 1.5 degrees Celsius. Some might say at because in the last few years, we've had different stretches of time over a 3-month period, over a 12-month period in which we've been above that 1.5 degrees. I think it's probably more accurate to say that we're pretty rapidly approaching it. But in any case, we are going to blow past this first threshold. What about 2 degrees Celsius? Under current policies, we are likely to blow past this threshold as well. People are going to debate as to when that's going to happen. The most aggressive estimates I've seen are as early as 2030, maybe more likely 2035, 2040. But that's our current policy. We had a lot of momentum with the Inflation Reduction Act in 2022 that allocated a lot of funding for both the development of new climate technologies as well as the deployment of existing climate technologies. Unfortunately, in 2025, on our domestic policy agenda, we're seeing that a lot of that, as well as other environmental regulations, are pretty actively getting rolled back. And so where do we stand? I'm not going to sugarcoat it. We're kind of in this shitter. This is not a great situation for us. And I think with climate change, it's really easy to be nihilistic or what's the point of it all? But we have to hold on to hope because it is something that can be fixed and we know how to do it. It's just going to require a lot of collective action. And remember, collective action is just made up of a bunch of individual actions. And if we're going down, I'm at least going to go down swinging. In terms of actions we should be taking, we should start with the biggest and lowest hanging fruit, and that's methane. Methane is an incredibly potent greenhouse gas, especially over the short term. On a 20-year time frame, methane has 85 times the global warming potential of carbon dioxide. Now, this decreases on a 100-year time frame to about 32 times, but that is still a huge multiplier effect. Now, methane is big time undervalued and overlooked when it comes to solving the climate crisis. Methane has contributed about 30% of all global warming to date, but in contrast, from a climate financing perspective, has only received 2% of all funding. We need to be prioritizing methane more. So methane you can think of as synonymous with natural gas. If you have a gas stovetop at home, the gas that's coming out is about 95% methane. Methane doesn't actually have a smell to it. The utility company just adds that in there such that you don't burn your house down. While an electric stovetop is better than a gas stovetop for the environment, that's not what's sending climate change over the edge. The 3 biggest sources of methane emissions are coming from the oil and gas industry, agriculture, and landfills. With the fossil fuel industry, we have infrastructure all over our country that is basically transporting natural gas through big pipes. And these pipes are aging infrastructure and have leaks in it. So we are basically pumping methane out into the atmosphere 24 hours a day and 7 days a week. And the thing is, we have the resources and know-how of how to fix this. We've launched satellites that can detect methane down to the square meter. We just need the oil and gas companies to actually patch them up. Now, with agriculture, methane is coming from cows, namely in cow burps, cow farts, and cow manure. Cows are a ruminant animal, meaning that when they eat and digest grass, they produce methane in their system. What's being done to address this? We have cow feed additives, researchers are working on vaccines, and there's also natural breeding programs. Lastly, landfills. When organic matter goes to decompose in an anaerobic environment, meaning when my food waste or lawn trimmings go to decompose in an environment without oxygen, such as a landfill, that decomposition process is going to emit methane. That's why if you have the ability to compost at home or in your city, it is an excellent action to be able to take as an individual, because remember, methane has an 85 times multiplier effect. The next concept you need to be aware of in addressing climate change is mitigation versus adaptation. Now, it's in the name, but mitigation is trying to stop the effects of climate change or stop climate change from happening altogether. Whereas adaptation acknowledges that climate change is already here and more is forthcoming. And so what actions can we take to adapt and live in a system where this is a new norm? Now, examples of mitigation might look like transitioning to renewable energy sources, decarbonizing across different sectors, maybe investing in the circular economy, or even removing carbon dioxide from the atmosphere itself. Adaptation, on the other hand, could look like building seawalls for flood-prone areas, developing more climate-resilient seeds in agriculture. It could look like wearable cooling technologies for outdoor workers, or maybe even buffering healthcare systems such that they're better prepared for heat waves. The large focus of all the work that's happened in climate today has mostly been around mitigation. And adaptation is really starting to kind of pick up a little more steam and momentum in the conversation, as it should. Because climate change is here. We're going to pass these thresholds. This is the new norm. Now, from a climate financing perspective, at most, depending on how you cut the data, 30% of funding is going towards adaptation. On the lowest estimates, around 5%. Most of this funding is coming from governments and multilateral development banks or the public sector, whereas the private sector, out of those funds, maybe only 2% is going towards adaptation. Quick plug, this is not sponsored at all, but the best resource for adaptation if you're looking to learn more is Climate Proof and what Louis Woodall is doing over there. Absolutely excellent work, and I couldn't recommend following it more. The next big thing to look out for, it moves beyond renewable energy generation into energy storage. So a few years ago in 2023, we passed this really big milestone where Lazard put out their levelized cost of energy analysis, which basically said that solar, wind, and renewable energy was cheaper to produce from a cost structure perspective compared to oil, gas, and other fossil fuels. And that's a really important milestone because people have been working for decades to get solar down that cost curve, and it finally reached it. So energy developers are deploying solar and wind over fossil fuel deployments, not because of the goodwill of their heart that it's a renewable energy source, but because it makes sense from a business perspective. It is just the cheaper option and alternative. Now, the next big challenge on the horizon is solving for one of the drawbacks of these renewable energy sources, specifically of solar and wind, in that they are an intermittent source, right? The sun isn't always shining and the wind isn't always blowing. And currently, fossil fuels are serving to plug that gap, whereas it can be solved with renewables if we solve energy storage. Right now, we can store energy on the grid for about 4 hours using our lithium-ion batteries. That's the same one as in your phone. But we need to move into something called long-duration energy storage, which is a relatively new and burgeoning industry. What would it look like if we stored energy for 10 hours or days or even weeks? There's a lot of different forms and methodologies that people are taking right now as to what that might look like. Energy could be stored in the form of thermal energy as heat and released back out to create steam and generate energy again when you need it. We're working on different battery chemistries like flow batteries and iron air batteries. In this situation, you don't need to solve for having a really small battery that fits around in your pocket if you're doing a utility scale installation. And then it could also be stored mechanically, which might be a pumped hydro or compressed air. So be on the lookout for the developments that are being made here. We need to talk about carbon removal, because even if we electrify everything when we transition to renewable sources and we solve for long duration energy storage, we're still going to face troubles because of hard to abate sectors in heavy industry that are notoriously difficult to decarbonize, like cement and steel. Cement and steel both make up about 8% of our GHG emissions each year. So together, they're about 16% of all our emissions. And it's a twofold reason for why they're so notoriously hard to decarbonize. In that one, you need really high temperatures, and two, it's part of the chemical process itself. So on high temperatures, to get a kiln up to like 1500 degrees Celsius requires a lot of energy density. And that's not something that electricity can supply yet. And then in the chemical processes itself, take for example cement. You start with calcium carbonate, which is limestone, and then you heat it to really high temperatures and it splits off into calcium oxide, that's your cement, and CO2 as a byproduct. It's unavoidable in this instance. So that's why we need CDR, carbon dioxide removal. Now, the predominant narrative around CDR is that we're going to need 10 billion tons of carbon dioxide removal annually by the year 2050. That is in 25 years from now. To put 10 billion tons or 10 gigatons in context, the US annually emits about 5 gigatons, so double the US's emissions. Where do we stack up against that? Collectively, in all the years leading up to 2025, we have delivered less than 1 million tons so far. So we have a long way to go. Now, the primary methodologies here, and I'll do a deep dive on this in another video, is direct air capture, biochar, and enhanced rock weathering. Let's talk about climate inequity. Climate inequity is the idea that climate change isn't going to be affecting everybody the same. This applies both domestically and internationally. Domestically, say you live in a coastal community that might be underwater in X number of years because of sea level rises. If you're the richest among that community or well-resourced, you could move yourself inland and avoid those worst consequences. Internationally, I'm going to use the example of the smallholder farmer who lives in extreme poverty and uses their 1 acre of land to grow crops to provide a livelihood for themselves and their family. Now, if you're already in a region that is susceptible to high heat, climate change is going to exacerbate those effects, right? You don't rely on central pivot irrigation as a smallholder farmer. You rely on rainfall in order to grow your crops. And if rainfall becomes more scarce, you can't grow your crops and you can't have your livelihood. What are they to do in this situation? The interesting thing about climate inequity is those that are most affected by it, those frontline communities, are the ones that contributed least to the problem. The smallholder farmer probably has a carbon footprint that is like less than 1/10,000th of my carbon footprint, yet they're left holding the bag of the impacts of climate change. Rich countries, rich communities, they have the resources to adapt. But what about everybody else? There will be climate refugees in our future. What are we to do about that? I think it's just something important to keep in mind that often gets lost in the conversation around climate change. You can't talk about climate change without talking about biodiversity, because biodiversity and climate change are two sides of the same coin. As climate change accelerates, we lose more biodiversity. So why is biodiversity important? Obviously, it's sad to lose life. Life is important. Like nobody wants to see a polar bear cling onto the last vestiges of some ice that it found, unable to find any food. That's no fun for anybody. But also, biodiversity is incredibly important to medical discoveries. Most of our medicine today comes from nature. Take, for example, ibuprofen, which came from the bark of a willow tree, or popular drugs today like Ozempic and other GLP-1s that came from the venom of the Gila lizard in the southwestern United States. The cure for cancer might literally be sitting somewhere in a biodiversity hotspot in our world. And when we lose biodiversity and we lose these species, climate change can be undone over the long term, but we can't bring a species back to life. Now, in these biodiversity hotspots, it's also critically important and interrelated with climate change because they serve as massive carbon sinks. Take, for example, the Amazon rainforest, which holds somewhere between 150 and 200 billion tons of carbon. Say the Amazon rainforest continues to get chipped away to make space for grazing lands. All that carbon gets released back into the atmosphere. And you can see where this becomes a vicious cycle because as more carbon gets released into the atmosphere, that accelerates climate change, creates drier conditions, wildfires are more likely to happen, and when those wildfires take place, guess what? All that carbon is released back into the atmosphere and the cycle repeats. So biodiversity is not only important for life and for medical discoveries, but protecting our biodiversity and our natural carbon sinks is one of the most impactful levers that we have in fighting climate change. Moving on to impact measurement. There's this old saying in business that says, what gets measured gets done. And when I think about why methane isn't getting enough prioritization in it, It's because we're using the wrong impact measurement metric. The most common metric that you'll see is something called CO2e, or CO2 equivalent. And this basically takes all the different greenhouse gases, CO2, methane, hydrofluorocarbons, whatever it is, and converts its impact in terms of CO2. Now, notably, this conversion happens on a 100-year time frame basis. So methane, which is 30 times more potent on a 100-year time frame, but 85 times more potent on a 20-year time frame, is going to be significantly undervalued when it comes to CO2 equivalents. Whatever methane that's being counted in CO2 equivalent right now should be worth 2.5 times more than it's being valued at today. Now, it's great that the industry has a standardized metric, because otherwise how else were we going to compare apples and oranges? But I think 100-year time frame is the wrong time frame. Solving for 21, 25, 100 years from now is great, but humans aren't particularly good at thinking about things on a 100-year time frame, right? 100 years ago in 1925, people aren't going to be thinking about like the driverless cars that we have out on the streets today. So when you hear CO2e, be cognizant that it is undervaluing methane. Let's talk about the voluntary carbon markets. So for a business or university that has made a net zero commitment, in theory, they're going to work on reducing their carbon footprint as much as they can. And for what they're not able to reduce any further, they're going to go use the voluntary carbon markets to purchase carbon offsets to bring that organization and entity down to net zero emissions. Now, not to be confused with the involuntary carbon markets, which would be your regulated cap and trade markets, like the EU ETS, CARB, or REGI. There's only a few examples out there. Back to voluntary carbon markets, if you've seen the John Oliver episode about it, the takeaway is basically some of the carbon offsets that are being sold on these markets are absolutely garbage. Carbon offsets were sold for trees to be planted that were never planted. Some of the trees that were planted went up in flames and wildfires. In even more egregious examples, these carbon offsets could have also been as low quality as saying that someone didn't cut down their trees, who didn't have really an intention to, but they didn't do so, and therefore they avoided the carbon emissions that otherwise would have happened, right? Just garbage. I think it's a fantastic thing for the voluntary carbon markets that these got highlighted. There's been an increasing shift in the last few years to focus not on quantity, but on quality. That is where carbon direct removal suppliers come into play. That's your DAC, biochar, advanced rock weathering, whatever it is. At the end of the day, I think what we're seeing in 2025 is a lot of the tech companies are rolling back some of their near-term net zero commitments and sustainability commitments because they're all worried about AI and trying to win that race. And I think that highlights one of the drawbacks of the voluntary carbon markets in that it's voluntary. The VCMs have a really important role to play in solving climate change, but at the end of the day, we cannot rely on them solely. Speaking of tech companies, there's been a lot of talk in the climate space about how AI is going to kill us not from going rogue, but because of its intensive energy usage. That I don't think is entirely true. Yes, AI has intensive energy use as well as water use, but it is just one piece of the pie. Data centers right now contribute about 1% of all energy-related GHG emissions, and projections for where this go in the future are all over the place depending on who you ask, maybe at 2x's, 3x's, 10x's. But the two things that I want people to keep in mind, first is that what we power these data centers with, whether it's renewable energy or fossil fuels, is going to matter a lot to the carbon intensity of what these data centers actually have. And the other thing is, the interests of climate folks as well as data center operators are actually aligned here, because from a business perspective, utilities, electricity, water is actually a huge component of the data center's cost structure and operating model. And they want to reduce that as much as they possibly can as well. Now, I say all of this not because I don't think that AI energy intensity is important or something that we should be paying attention to. We absolutely should be. I say this more because I see a lot of climate folks shying away entirely from using AI and shaming others for their use of AI because of its carbon footprint. But I want to make it very clear. You should not shy away from AI usage just because of climate concerns. I think it's okay and a very good thing to do to want to minimize your AI usage, right? Like don't send 25 prompts through Google VO3 because you just thought it was interesting. But you should not shy away from it entirely. The world of work is changing. AI is going to be happening. Unfortunately, the technocrats have already decided that for us. Artificial general intelligence might be here within the next 5 years. And I think on this time frame in which we're fighting climate change, I just don't see a world in where if we as an industry avoid using AI, how we could possibly win the fight against climate change. If you're still struggling around the idea of even engaging with or using AI, I want you to consider it this way. If your use of AI helps move the needle even a little bit in any of these other massive pieces of the puzzle, then it is worth your time and investment. There is so much more to climate change and how it intertwines with business, financial markets, and economic development that I would love to share with you, but certainly does not fit within the confines of this video. Look, this channel is all about how business and finance can be a force for good, for people and for planet. And I want to help you build a meaningful and purpose-driven career. So if you're interested and you learned something today, be sure to check out my other videos and hit the subscribe button. See you in the next one.